Hello, I am Amalia Velasco from the Spanish Cadastre, and I am going to tell you about the 3 modeling and representation of the Spanish Cadastral cartography and the inspired buildings model. So first, I am going to explain how is the Spanish Cadastral data about the buildings, how we manage to put this data in web map service in 3D, how we modeling, and then I will explain how we manage with the inspired model, which problems we have, and what we need to do to can offer the data in inspired model, the buildings data. The Spanish Cadastre is a register describing rural and urban real estates. These descriptions include physical, legal and economic characteristics, location, cadastral reference, address, surface, use, class of crops, buildings, graphic representation, time attributes, cadastral value, and data of title holders of properties, name, national identity number, address of the holder, the type of the title, and many other data, many other data. The Spanish Cadastre is principally a fiscal cadastre, whose database of cadastral values of rural and urban real estates are the basis for the calculation of real estate tax and other local, regional, and national taxes. We need the information about the buildings mainly to make the taxation. So we need more information than only the parcel or only the building. We need also the information inside the building, the distribution of each property and the common areas. And how we do this? We have an exchange document that is, we call FXCC, that is a scale graphic representation of the properties forming an urban real estate building. In every exchange document, the different floors and interior space are represented. The document contains a digital photo of the building too, and is stored in the database parcel by parcel. This exchange format is the way that the collaborative institution gives us all the information of every flat in the data. So, for example, this is the parking floor, this is the first floor, maybe these are from the 2nd to the 7th, and we have also the general representation of all this in one document. This document is stored in the system as documental information and linked up to parcel data by means of the cadastral reference. The Spanish Cadastre has information of 12 million urban parcels, 32 million urban units, and 42 million rural parcels, all in a continuous and uniform model. In the urban areas, the parcel contains urban units, flat individual parkings and other units inside the real estate. Every unit has its own cadastral reference, and all the urban units of a parcel have the same first part of the cadastral reference. The link between alphanumerical and information and graphic information is achieved using the cadastral reference. So we have every unit with the reference. The buildings in the maps are defined as subparcels, as a volume constructed. Cadastral cartography, even if it's only in 2D, has the volumetric information of the buildings by number of plants in Roman numerals in their maps. So we have for every flat one document, but also in the map we put every volume, if it's two floors or 3 floors, one under the ground and 2 floors over. So in this way, with subparcels, we describe all the buildings. Another important part of the Spanish Cadastre is that we give all this information, and we take all this information through internet, through the Spanish Cadastral virtual office. And the Spanish Cadastre is a pioneer public sector organization in its facilitation of access and reuse of its data for free for both commercial and non-commercial purposes. The Spanish Cadastral service by internet gives cost-free, easy, rapid, 24 hours, 7 days a week access to all this data that I said. It has evolved from being a governmental tax collection and a real estate security service to being a social value tool, since this data is used in an increasing numbers of applications and new services. This approach has led progressively to a huge success in demand, with more than 8 million access a day and more than 5.2 million of certificate issues in 2011. So with all this data, we can produce web map service free of charge with all the information in 3D. Okay. So we base our web map service and the modeling of the 3D cadastre in a layer that has the information of the number of floors in numerals and other information about terraces, gardens, swimming pools, etc. All in one layer. That it will be the layer that we will use in the web map service to produce the 3D. And how we do this 3D? We can manipulate, because we do our web map service, we develop our web map service, so this we can do because we can change the characteristics and the symbols and the representation in the way that we want. So with this construct layer, with all this information that I told you, what we do? We do two ways. One is based using a shading to give highlight aspect of the buildings. And other is the representation in cavalry perspective each constructive element. This we do taking care the number of floors of every building. And if you use the perspective layer, we order the subparcel from north to south. Each subparcel is drawn in its real position with semi-transparent. For each pair of consecutive coordinates that make up the subparcel, we construct a parallelogram in the north-south direction and with the different scale by a factor multiplied by the numbers of floors above the ground of the level. And we draw the cover of the generated prism. It is an object with the same geometry at the base, but with a shift toward the north of the image based on the factor by the number of plants. In this easy way, we can see the buildings in 3D. But this is not important. The important is the modeling that we develop. We have developed in the most easy way for us 3D by parcel in the CAM-ML format. Also in two ways, based on the 3D components that I showed you in the map, or also using every sketch for floor. So in two ways we can show the 3D. The modeling is not storage in the database because it will be huge, but is performed in real time on the basis of the factor information of the geometry of the objects. Yes. So we have one model that is based in the general floor, taking the attribute of the construction, the number of floors, like we use for define the C component. And the other is using all the sketch based on the generation of independent units models with the vector information in the cadastral sketch by plans. In the general floor model, we use the cadastral cartography in vector format of each parcel and the number of plants multiplied, for example, and we use by 3. That is what we have estimated a priori in meters as average height of each plant. The 3 model by extrusion is generated for each subparcel of the parcel to can describe well the model. If we want to build the 3D model with general floor, we can, from the KML, to have a link with the cadastral reference to get all the free data in our model. If we do in the other way, using the information of this exchange model that we call FXCC, that is with every floor, how we do it? Each part of the building can be then geometrically represented in 3D dimension with the physical space in the building. So, in this way, even we can give to each unit, for example, a color depending on its use, owner, value, or any other attribute that we have. Some examples. In the presentation, I give you links to the examples if you want. We also have the time parameters, so we can offer also exchange format in KML in 4D, and we can give other formats. So the conclusion before INSPIRE is that the cartography of the Spanish Cadastre can be modeled in 3D. The idea of representing 3D objects in a web map service for a tax office like us is totally new. The automatic extrusion of 3D database on simple schemes that allows the reconstruct of a large amount of data and offers a good solution of the demand for such a product, increasingly requested by users. These products are very much requested for users. For cadastral purpose, we don't need to store complex 3D models with description of texture opening. Simple 3D visualization is enough for our current users. But then came INSPIRE, and what we should do. First, we, as a main building data provider in the Spanish spatial data infrastructure, we have participated in the INSPIRE thematic working group for buildings. And as is analyzed, the first thing that we see is that it's very different, the cadastral data of the buildings, than the topographic data of the buildings. And there is always a conflict in the way that you want to model in. And we must arrive to a compromise, because we must look for the level of interoperability just right for the balance change. So if you have seen the model of building, it's quite complex, but it's not so complex as it seems. We have a base package with the common semantic on abstract building and the common data types and code lists. But then we have 4 profiles. 2D with the base information, that is the core information and the only one that is obliged for the data producers. Then a core 3D information, also with the things that they are obliged. And then we have an extended 2D and extended 3D information. In the core 2D, for us, for the Spanish Cadastre, is very important. It's very important to see that there is building, but building part also, and they are factorized in an abstract building with geometry in 2D. What it said in the INSPIRE specification is the buildings are enclosed construction above and/or underground, which are intended or used for settle of humans, animals, things, or the production of economic goods and that refers to any structure permanently constructed or erected in its site. But then he said that the building can have building parts, and the building parts compose the building. A building may be a simple building with no building parts, or a composed building with several building parts. For us it's important because, as I told you, we don't have the building, but we have the different volumes construct, every building part. A building part can be because the number of floors are different, but also can be because the use is different. Not the use, but one is swimming, the nature is different. So in this way we can represent our buildings in Inspire, but we have to build the building because we don't have the building. We have the parts of the building, and we must put and create an identifier, because Inspire make obligation that every building and every building part has an identifier. So it will be a lot of work for us. We will have to adapt our complete classification, much more complete than the Inspire, to the much more simple classification of Inspire. But this classification can be extended, can be a code list extended. But we have problems to understand, like data producers, how we are going to give all our buildings that sometimes are hospitals and other farms and industry, how we are going to provide this in Inspire. Because in the classification of buildings, only we say industrial, and we have much more data about if it's the parts of the industry, and much more data, and we don't know how to do it. And the other, we will apply the core model of Inspire, only the core model, like I think that 100% of the data provider. So we will offer very little data of our huge data, because I think that probably no one is going to go to the extended model. But what is good is that we put the external reference to the cadastral data, and it will be possible to link with our complete data through the cadastral reference. In the core 3D, also they have the building part, but the geometry is very difficult to get for us. They use the CTGML, and we cannot provide the 4 levels of CTGML, mainly because we have internal composition of the building that is in the 4 level, but you must go through the other 3 before. So CTGML stores geometry, topology, and semantics in the building model, and we cannot. In the extended 2D model, there are much more information, and we can provide this information. There are 5 instance features: building part, other construction, for everything that is not real a building, but is important to have in the map. It is necessary to describe the landscape, like towers and many other things. And we have the building units and the installations. And it's important because in this extended, for example, in the case of the cadastral, they have the value, that for us is very important, and you have it has the document that permit us to have this exchange format that we have. But also have the floor distribution and the floor description that will permit us to describe all this data in a literal form, all this data that we have for every floor. So we can describe the ground floor and the 7 floors above the ground floor, that they are different, but only describe. In the extended 2D, there are the building units, of course. And these building units have the area and the official value. So in the Spanish Cadastre, the building units are important because are the flats where the people live. The people live in the cities in condominiums, and everyone owns his own flat. So it's important for taxation, and it's an important part of the Spanish Cadastre. But it's not an important part in the Inspire model. The Spanish Cadastre is a fiscal cadastre, and the value of each unit is the basis for many taxes, as local property tax. To be able to provide our building units in Inspire model, we should give one identifier of every unit that we have, but we must also give the geometry in the 2D or in the 3D model, if we are going to provide in 3D model. So which are the conclusions? But we will have to build the building from the building's parts, and to create an identifier, we will have to adapt our complete classification of buildings to a much more simple classification. If we apply the mandatory core 2D model of Inspire, that will be sure the most likely scenario, we will offer very few data regarding that we will have been able to provide. And maybe in the future we can apply extended 2D model and offer more 3D related information via floor description, floor distribution, and documentation. Our way to provide 3D visualization of buildings in KML is not enough to fill the 3D model of Inspire. However, we should keep this kind of view service that is of great interest for our users. Okay, I think. To be able to offer our building units in Inspire model, we should give geometry 2D or 3D an identifier, and we don't have it. So thank you very much.
Thank you very much, Amalia, for this interesting presentation. And I'm sure that there are some questions in the audience. Are there any? No? Seems so. So maybe, there is one, okay. Do we have microphone? Yeah, it's coming.
Service Latvia. I have a question about this, how you make this from stair. You saw that you make these buildings from inventorization models which are in raster, yes? These are vectorized? These exchange formats?
It's vector. All is vector.
All is vector. And when you make these buildings, yes, they are you took first floor, took these meters, height, then other meters, so on, yes?
Yes.
Thank you.
Okay, some more? Yes, please.
Yes, Jarosław Bydłosz and University of Science and Technology in Krakow. My question is, and is the building or building part the object of cadastre in Spain, or there is some different solution?
The building is an object in the no. The building parts are the object in the Spanish Cadastre, not the building. The building parts.
Yes, so I understand that you are building a building from building's parts. Yeah.
Yeah.
So thank you very much.
Any more questions, maybe? It seems no. Anyway, the 3D information are very, very important, I think, nowadays, so we can expect more improvements, probably, in the future.